exactly are waves? Now, as we have understood that the waves are associated with the different forms of energy. Energy basically is in the form of kinetic energy. There are pressure waves, there are displacement waves, and so on. So obviously there is some amount of energy that is associated with it. Let's try to understand about what are the different forms of energy that are associated with the waves.
Energy and equation of a wave. We need to understand how the wave can be represented in a three-dimensional space. The representation of wave is very, very important. Wave characteristics have to be captured into the form of an equation. So let's try to understand what basically are the things which characterize a wave. So first of all, if you have to talk about a wave which is actually moving. So if it's moving, its complete plethora has to move forward. So let's say here we have this particular wave. So it's a sinusoidal function which is given by this. We're talking about a general wave, a very simplistic one, which has an amplitude given like this. It is moving with a speed v, and so obviously with time a speed v is going to be taking it further, and as a result there is a change in its displacement. So here if you have to write down, because it's a sinusoidal function, so we can write down in the forms of sine, and since there is also a factor of v into t, so we need to take that into account as well. So what exactly is k? K is defined to be nothing but the wave number. So here, if there is any particle at this point, let me change the color so that it makes more sense. Supposing you have any particle here, so there is going to be an acceleration that's going to be acting towards the center, right? And as a result, the acceleration is going to be given by negative, or it's going to be proportional to the negative of the displacement. And the maximum acceleration is going to be given by minus omega square times a. At this point, the velocity is going to be directed towards the negative direction. There is no motion taking place along the y-axis. There is a maximum velocity, but there is no motion taking place at all. So the general expression is going to be given by, if we assume it like this, so 2 pi by lambda is what we define as the wave number. So if we take that factor out, so obviously as you keep on translating it, so obviously there is going to be a factor of v into t that you need to take into account. So if you do that, so effective displacement is going to be given by x minus vt. So you can also write down this displacement as equals to a sine, if you take the 2 pi by lambda factor inside, so we'll get 2 pi over lambda into x minus 2 pi over lambda into vt. As a result, this expression can simply be given by a sine kx minus omega t. So 2 pi by lambda into v, that is v by lambda you can write down in terms of the frequency of the wave. Frequency 2 pi times frequency is what gives you the angular frequency. Yeah. So this is the general expression. Now if you try differentiating to find out what exactly is going to be the velocity, so the velocity expression is going to be given by omega times a. Omega because this particular factor, because if you are differentiating with respect to time, if you are taking it out, so obviously the factor of omega is going to come out with a factor of cos. So cos 2 pi by lambda into this, and then if you differentiate it again, it's going to be giving you minus omega square into this. So this is what, this gives you ay x comma t is equals to minus omega square into y. So this is the expression of a wave. Now let's try to understand about the energy. So the energy of a plane progressive wave, if you have to understand that. So for this, let's consider a velocity, a plane wave with propagating with a velocity v along the x direction. It has an area of cross section, let's say S. If you take an element of material medium, let's say density rho. So density is equals to rho, and that has to be multiplied with the area. S is what? S is the area of cross section, dx is the small displacement. As a result, if you want to write it down further, we'll say y equals to a sine omega t minus kx, which we already know. Therefore, what is going to be the total energy? We can find out the total energy. How? So rho into s dx, this is what? This is nothing but the mass. Yeah, mass we know, and a velocity square, half mv square is, this is how we define it, right? So a omega, a is basically the amplitude into, because it's the outer surface, how much is the amplitude that is moving. So amplitude into the rotational velocity or the angular velocity whole square. So if I simplify that, so that gives me rho into s dx into 2 pi square f square a square. As a result, if I try to find this out, so this gives us the energy density. Why? Let me change the color. Because dE is the energy, so dE divided by this being the mass. So dE divided by, if you look into it, this is density, so density is mass per unit volume, this is the volume, so effectively dE divided by dm, that will be giving you 2 pi square f square a square. Or if you want to find out in terms of volume, in that case just write it as dV, and here we'll be having a factor of rho. So that's what is the energy density, that is the energy per unit volume. Moving on, energy per unit length you can find out, and similarly once you know how much is the energy per unit length, you divide it by the time taken. So once you know how much is the time taken, so that gives you the power transmitted. Now if you move on, we need to understand how exactly are the waves are moving in a stress string. So supposing you take a very small mass that is hanging, right? Or for the instance, if you try to pluck the case of a guitar string. So if when you pluck the case of a guitar string, the guitar starts moving along the vertical direction. There is a motion taking place along the vertical direction, as well as it also transfers its energy in the forward direction. So if you take a small mass of the string here, so if you take a small mass of the string in the circular path of radius r, which is moving at the speed v, there is going to be centripetal force as well. So the centripetal force that's going to be acting is going to be balanced by the tension. As a result, but you will say that, let me just draw a figure for this as well, so that will make sense more. So here, if you see that this is the wave that is moving here, there is a tension that is going to be acting towards the center, the velocity is moving towards the right. The tension that is here is going to be produced by this particular weight. So if you try to take an angle at any point on this particular string itself, so here you take a point here, you take a point here, and take it directions like this, right? So with respect to the horizontal, these angles will be equals to theta. Further, if this is the point, the velocity is moving towards right, you take this particular point, let me change the color. So I'm talking about this particular point, this has a mass dm, let's say. As a result, what you will get, the force that you will have is going to be given by 2t sine delta theta. So 2t sine delta theta, if we are taking it, so we can just assume that theta is very, very small. So sine theta is nothing but, sine delta theta is nothing but delta theta. So if we just rearrange it, so we can write this as approximately t times 2 delta theta. Now 2 delta theta here, that is basically this particular angle. So this is going to be equal to twice of delta theta. This is the small angle that we are referring to. So this can be written as, since this is the radius r and this particular length is the extension delta L that is taking place. So force is going to be equal to T delta L divided by R. Now, this is the force that is acting on that particular segment. Therefore, if you now want to find out how much is the mass, so the mass delta M is going to be given by mu, which is the mass per unit length, into the length of that particular portion. Using that, what will we get? Because there is a centripetal force, we know that mv square by r is the centripetal force. So if I equate that to A into T or A into R, I should be saying, the mass, if I just get cancelled, so this gives us the centripetal acceleration. So putting it all together in perspective, we'll get T delta L by R, which is going to be equals to mu into delta L into V square by R, because it's the force that we are referring to, mind you. So mu delta L is nothing but the mass, the small amount of mass on which the force is acting. So mu delta L into V square by R that we have. So if we equate these two, if we equate this to this, so that gives me the velocity of the waves that are moving in this stress string. Let's move on. When we are talking about the transverse vibrations, we have already found out how much is the velocity. So using the velocity, we can also find out what is the frequency of motion. because there is an angular velocity. So using this value of frequency, we can find out three different cases. So what are the three different cases? There is a law of lengths, according to which the frequency is going to depend upon, inversely speaking, to the length of the string. Then we have the law of tension, that the frequency depends only upon the tension, with the mass per unit length being constant and the length also being constant. The law of mass, according to which the frequency is going to be inversely proportional to the square root of mass per unit length, that is mu. So this is what we have. So please understand that whatever is the extension, that is going to be dependent upon the tension, because the tension is being produced with a mass. There is also a length. Here we are assuming that the length to be uniform, or the mass per unit length as well to be uniform. There should not be any non-uniformity, else the frequency will be going to change. We take generally, for the case of a sonometer, we take a 1 meter length, but you can have a variable length here because it doesn't really matter. So using these things, these are the three laws that have to be taken into consideration. Hope you understood till this point. Let's meet again. Thank you.
Here, we talked about the energy associated with the waves. Then, we also understood about how the energy is related to the energy per unit volume, that is the energy density. It is the energy density that is transferred because we assume that the waves are uniform. So, if the waves are uniformly distributed, obviously the energy density is the one that is constant. Now, since the energy density is constant, we need to now understand that if there are multiple waves, then what is the resultant of those two waves, or those two or more waves? That is what we understand in superposition of waves.